Hi, I'm Sarah.
And I'm Liz. Today we're going to talk about the dark universe.
So put your grown-up pants on because there's no room for nyctophobia and cosmic adventures. That's the fancy word for fear of the dark.
All right. Well, there's no reason to be afraid, though there's seriously a lot of dark stuff out there.
Astronomers have been finding evidence of invisible matter and energy for decades. Even though they can't directly see this stuff, they can detect its influence on the stars and other luminous matter.
Dark matter creates a scaffolding of structure across the universe on which everything else is built. Normal matter traces the densest dark matter regions. That means each galaxy that you see in space has way more invisible mass surrounding it.
Scientists know that this matter can't be made of atoms, like you and me, and dogs, and stars, and dust, and gas, because it doesn't emit or absorb or reflect light. Thus, it must be something we haven't yet encountered. But astronomers had to name it, even though they had no idea what it was, so they called it the vague but accurate dark matter.
One idea for dark matter's secret identity is what scientists called a weakly interacting massive particle, or WIMP. Collisions at the Large Hadron Collider in Europe should create this particle if nature can make it, if it's not too much of a WIMP.
I can't really believe that you just called nature a WIMP. I mean, it's literally right here. It can hear you talking.
Just kidding. Geesh. Dark matter is a lot of the universe, but even a larger portion of the cosmos is what's called dark energy. Scientists know even less about this stuff.
When I was a kid, that was the kind of statement that would have inspired me to proclaim that I was going to be the one to figure dark energy out.
You had very lofty goals as a child. Pretty much all scientists have been able to figure out so far is that dark energy is some kind of force that counteracts gravity and makes the universe expand faster and faster.
But no one knows what it is.
So, to help you visualize how much of the universe this dark stuff is, we have a demo! Yay!
Our demo starts with this jar and these beans, and we're going to fill this jar with the component parts of the universe.
So here, we're going to start with dark energy, which is about 68.3% of the universe's total content, and we have black beans to show the dark energy portion.
Kind of losing. Dark energy is escaping the universe. And then we have these red kidney beans, which represent dark matter, which is about 26.8% of the universe.
And lastly, we have white kidney beans, which represent the baryonic or normal matter, such as Sarah, me, our dogs, this table, these bowls, and makes up 4.9% of the universe's composition. A very dark universe, indeed.
This is where you live.
So remember that 4.9% of the universe that's actually made up of normal matter? Now this demo is going to show you what that tiny little 4.9% is actually made up of.
And 92.38% of the normal matter in the universe is navy beans, which
Yes.
in this case actually represent intergalactic and intracluster plasma, all the hot matter between galaxies and galaxy clusters. So.
Hopefully this goes better than dark energy.
This is science problem solving. Good, there we go.
So now the next largest portion of regular matter is made up of main sequence stars like the sun, supermassive black holes at the center of galaxies, and bulges, which are also sort of the central galaxy component. And those are represented by small red beans, not to be confused with the red kidney beans in the dark matter demo from before. This is 4.53% of the universe. That went much better.
Good job. The next thing we have is the hydrogen and helium gas that's in the universe, which we always think of as being a huge component of the regular matter, but it's actually only 1.37%. It is represented by pinto beans, which it turns out have spots on them, even though I didn't know that because I don't eat enough pinto beans.
Next, we have black-eyed peas, not to be confused with the group of the same name. These represent substellar objects, which are things like brown dwarfs. And these are about 1.06% of the regular matter in the universe.
And molecular gas, or gas that's composed of more than one atom stuck together, represents 0.35% of the regular matter in the universe. And today we have garbanzo beans playing the part of molecular gas. They look, 5 of them, they look delicious.
Then, one of the last things, we have lima beans, tasty of course, to represent compact stellar remnants, so things like neutron stars, white dwarfs, and stellar mass black holes. Now we just have a few, just 5 of these, with lima beans. These represent 0.31% of the normal matter in the universe.
And lastly, we have planets, which we've been discovering more and more of as time goes on, but they're still only a tiny fraction of the mass of the universe. They are 0.0013% of regular matter. They are all inside this little tiny lentil.
There you go. All of the regular matter in the universe, and that's just a very small portion of our greater universe.
It gives you a sense of how much of the universe scientists really don't understand, and how much the future hero scientists of the world have to discover.
And how complex ordinary matter is. It's pretty unlikely that all of dark matter, so that 26.8% of the universe, is just one type of particle, the WIMP. Chances are there's a lot of other stuff that makes up dark matter.
Like black beans floating in space, perhaps. They wouldn't reflect a lot of light, and it would only take 1 tredecillion beans to account for the necessary mass.
And as you can see here, that's a 1 with 42 zeros after it.
No problem. That's what the bulk section of the grocery store is for. We look forward to hearing what scientists find out about the dark universe. There's a lot left to understand.
And that's one reason why cosmology is so darn exciting. I couldn't say any bad word there, so I had to say darn. What do you find most interesting about this field of astronomy?
Let us know in the comments below or through email. Until next time,
Bye.
they can detect its influence on stars and other luminous matter.
We have a problem.
Action.
So the next largest, okay.
Wait a second after I say action to get into it.
Cool your jets.
Action. Action.
So now the now I'm having just, I can't function. Okay.